Hashtag mobile chip performance comparisons, long-form script. You're comparing phone chips wrong. And it's costing you thousands in wasted money on devices that don't match what you actually need. Here's the truth, most people look at one benchmark number and think they understand performance. They don't. They're missing the entire picture. And today, we're breaking down exactly how mobile chips actually work, what those numbers really mean, and how to pick the right processor for your life. Welcome back to TechNavigator Pro, where we help you navigate your tech journey with confidence. Let's start with the problem. You're probably scrolling through phone specs right now, seeing something like Snapdragon 8 Elite or Apple A18 Pro, and you have no idea what that means. Is it fast? Will it handle your apps? Can it run games? You're guessing. And when you guess on a $1,200 device, that's a costly mistake. The real issue is that chip manufacturers don't make it easy. They throw around terms like CPU cores, GPU performance, and single-thread versus multi-thread scores. It's intentionally confusing. So let's demystify this. First, understand what a mobile chip actually does. Your phone's processor, sometimes called a system-on-chip or SoC, handles everything. It runs your apps, processes your photos, streams your videos, and manages your battery. It's the brain of your phone. And different chips do this differently. Here's where most people get lost: performance doesn't come from one number. According to AnandTech's mobile processor analysis, real-world performance depends on CPU architecture, GPU capabilities, memory bandwidth, and thermal management working together. Not just one metric. Let's break down the CPU architecture first. Think of this as the thinking power of your phone. Modern mobile chips use what's called heterogeneous computing. That means they have different types of cores doing different jobs. You'll see terms like performance cores and efficiency cores. Apple uses this in their A18 chips. Qualcomm uses it in the Snapdragon 8 Elite. MediaTek uses it in their Dimensity processors. Here's what that means: performance cores handle intense tasks, gaming, video editing, processing. Efficiency cores handle background stuff, email, notifications, light browsing. The system switches between them intelligently to balance speed and battery life. This is why a newer chip with fewer total cores can outperform an older chip with more cores. It's not about the number. It's about what those cores are designed to do. Now, when you look at benchmarks, and you will see these everywhere, understand what you're actually reading. According to Geekbench's methodology documentation, single-thread scores measure how fast one core can work. Multi-thread scores measure how many cores work together. Gaming performance depends on GPU benchmarks, which are completely different. Video encoding uses specialized hardware. Photo processing uses the neural engine. This is critical. No single benchmark tells the whole story. If you're finding this valuable, hit that subscribe button. We post tech tutorials daily that break down confusing tech into simple truths. Let's get into the actual comparison structure. When evaluating chips, you need to look at 4 specific categories. Category 1, CPU performance. This is where you compare single-thread and multi-thread scores. Use Geekbench 6 or Antutu as your reference points, but understand these are synthetic tests. They don't reflect real usage perfectly. According to Tom's Hardware's mobile processor benchmarks, the Apple A18 Pro currently leads in single-thread performance, with the Snapdragon 8 Elite close behind. But here's the key: in actual daily use, you won't notice the difference. Both are incredibly fast. Category 2, GPU performance. This matters if you game a lot. Open GFX Bench or 3D Mark on your phone. Yes, you can actually test this yourself and run the same benchmark on different devices at a store. Watch the frame rates. Per GSM Arena's testing methodology, consistent 120 frames per second in demanding games indicates excellent GPU performance. The A18 Pro and Snapdragon 8 Elite both achieve this. Category 3, efficiency. This is the battery life factor. A faster chip that drains your battery in 4 hours is useless. According to recent teardown analyses by iFixit and similar sources, newer chips like the A18 and Snapdragon 8 Elite use 3nm manufacturing processes, which means they do more work with less power. Look for this specification. Smaller nanometer numbers equal better efficiency. Category 4, Thermal Management. High-performance chips generate heat. How does the phone cool itself? Some use copper vapor chambers. Some use graphite layers. Per manufacturer specifications found in detailed reviews, sustained performance under load reveals thermal design quality. If a chip throttles, meaning it slows down to cool down during gaming after 10 minutes, that's a red flag. Now here's where it gets practical. Let's talk about real-world scenarios. Scenario 1, you're a casual user. Email, social media, messaging, light browsing. You don't need the absolute flagship chip. According to market analysis data, even mid-range processors like the Snapdragon 7 Gen 3 or MediaTek Dimensity 7300 handle this beautifully. You'll save hundreds of dollars. The performance difference? Imperceptible in daily life. Scenario 2, you're a content creator. Photos, videos, editing. You need strong CPU and GPU performance, but you also need speed for rendering. Look at the neural engine specifications. This is the AI processing hardware. The A18 Pro has a 16-core neural engine. The Snapdragon 8 Elite has dedicated AI processing. These speed up photo editing and video export significantly. Test this yourself in apps like Adobe Lightroom or CapCut. Open the export panel and watch the speed difference. Scenario 3, you're a mobile gamer. You're playing demanding titles like Genshin Impact or Call of Duty Mobile at maximum settings, 120 frames per second, consistently. You need top-tier GPU performance and sustained thermal management. The A18 Pro or Snapdragon 8 Elite are justified. Anything less will show frame drops. Test this by watching the frame counter. Most gaming apps have this setting. Scenario 4, you want longevity. You're keeping this phone for 5 years. Look at the chip's generational lead. According to industry analysis, a flagship chip from one generation has roughly 1.8 times the performance of a flagship from 2 years prior. If you buy last year's flagship, in 3 years it'll feel noticeably slower. If you buy this year's flagship, it'll feel snappy for 5 years. The math matters for long-term value. Here are the specific chips you should compare right now in January 2026. Apple A18 Pro, 6-core CPU, 6-core GPU, 16-core neural engine. Top single-thread performance. Exceptional efficiency. Best for iPhone 16 Pro users. Snapdragon 8 Elite, 8 cores including performance and efficiency variants, Adreno GPU, dedicated AI engine. Matches A18 in multi-threaded workloads. Found in flagship Android devices. MediaTek Dimensity 9400, competitive performance at a lower price point. Good thermal management. Popular in Chinese and Southeast Asian markets. Samsung Exynos 2500, custom architecture, strong GPU performance. Found in Galaxy S25 models in some regions. Now, the advanced tips that separate people who understand chips from people who just read marketing. Tip 1, Cache matters. The size of L3 cache affects performance. A chip with more cache can access data faster. Look at detailed specs on manufacturer websites. The Apple A18 Pro has larger cache than previous generations, which is why it's faster. Tip 2, memory bandwidth is invisible but critical. This is how fast data moves between the processor and RAM. Higher bandwidth means smoother multitasking. Find this in AnandTech's detailed technical analyses. It's in the specifications but rarely mentioned in marketing. Tip 3, manufacturing process matters more than core count. 3nm versus 5nm is a bigger difference than having one more core. Smaller nanometer equals faster and more efficient. This is physics, not marketing. Tip 4, thermal throttling reveals the truth. A chip might perform amazingly in the first 30 seconds, then slow down. Real-world performance means sustained performance. Test this on devices at a store. Run a demanding game for 5 minutes and watch if the frame rate drops. Tip 5. Driver optimization matters. A chip can be powerful, but if the software doesn't optimize for it, you don't get the benefit. This is why iPhone gaming often feels smoother. iOS optimizes tightly for Apple chips. Android has more device variety, which can mean less optimization per device. Tip 6. Your actual usage matters more than specs. This is the truth nobody wants to hear. If you use social media and messaging, even a mid-range chip feels fast. You're not actually using the high-performance cores. Don't overpay for specs you won't use. Here's what you actually need to do right now. Step 1. Identify your actual needs. Write down what you actually use your phone for daily. Gaming? Video editing? Just browsing? Be honest. Step 2. Research benchmarks for those specific tasks. Don't compare everything. Compare what matters to you. Step 3. Visit a physical store and test the phones. Open your most used apps. Feel the responsiveness. This is more accurate than any number. Step 4. Check the thermal performance. Use a demanding game for several minutes. Does it stay smooth? Step 5. Compare prices. A chip that's slightly slower but $300 cheaper might be the smarter choice. Step 6. Consider longevity. Are you keeping this phone for 2 years or 5 years? That changes the chip recommendation. Step 7. Check reviews from AnandTech, Tom's Hardware, or GSM Arena for real-world performance testing, not just benchmark numbers. Step 8. Make your decision based on value, not just performance. A flagship chip doesn't guarantee a flagship experience if the rest of the phone isn't optimized. The biggest pro tip: stop comparing chips in a vacuum. Compare the entire phone system. A mid-range chip in a well-designed phone often feels faster than a flagship chip in a poorly optimized phone. The hardware is only part of the story. Software optimization, thermal design, screen responsiveness, these all affect how fast your phone feels. And here's the secret that phone manufacturers don't want you knowing: generational improvements are getting smaller. According to industry analysts, the jump from the A17 to the A18 was modest. The jump from the Snapdragon 8 Gen 3 to the 8 Elite was moderate. You're seeing diminishing returns. That means if you have a phone from last year, upgrading for chip performance alone isn't worth it. This is the honest truth. One more critical insight: battery size matters as much as chip efficiency.